we're going to do a 0.1 inch radius bend, except instead of in the middle of the cable, we're going to do it really close to the back end of the connector. There's a lot of concerns and there's a lot of worries about making bends really close to the end of the connector, especially on soldered assemblies, because of the fear of cracking any of the solder that may have wicked down the braided down the braid on the outside there. So once again, we're looking at the VSWR numbers here and at the graphs, and we're going to try to observe if these change at all significantly. So I'm going to go ahead and move this here right about here in the back end. I'm going to try to make a 90-degree bend against this mandrel. There we go. As you can see, we're still right at 1.9, 1.19, 1.2, right around there through 18 gigahertz. This type of performance is better than most of what you'd expect out there for any cables out of the box, let alone with a 0.1 inch radius bend right next to the back end of the connector. As you can see, the connections do hold their bend as well. At Gore, we have the capability of obviously locking those bends in place by putting a piece of shrink tube in any specific location down the length of the cable to help you hold the bend, but the cable itself is able to hold it as well. With that, I hope I've shown you that this cable is very robust in these types of applications and can handle very tight bends. In addition, very flexible. For any sort of routing needs, it can go right back to being flexed to wherever you like it, whatever position. And the performance has not changed. Still very, very good, very uniform. No clear effect to or degradation of your VSWR or your insertion loss curve.